All right, you're welcome back again. I want to look at clustering in past. Clustering. In machine learning, we have supervised learning and unsupervised learning. And clustering falls under unsupervised learning, whereby data is clustered based on algorithm. When I say cluster, I mean categorized automatically using in-bit algorithm, or data is segmented. So that is exactly what we want to look at. In past, we can do the same in past by using clustering functions. There are many clustering functions in past. So now we have gotten our data, our PCA data, so we can use it to cluster. Meanwhile, when you're clustering, you don't need to include the categorical variable. That means we are trying to say that there is no uh, there is no label. Okay, in clustering, it means there is no label. Labeling is missing. That's what it means. So that's why we want algorithm to do a clustering to cluster for us automatically by itself. That is the purpose of clustering when you have no label data. So we are going to exclude the categorical variable there, which is race, to be included, so that the algorithm will do the clustering by itself automatically. So the first clustering we're going to look at is called hierarchical clustering. Hierarchical clustering. This is very common in unsupervised learning algorithm, and we are going to see how we can perform that in R. So let's copy this to R first. To pass other, sorry, to pass other. Sorry, I use R to pass. So we paste here as usual. Group. I'm going to remove this. Right. So now let's color this first so that you can see the color. We have black. Let's say we have blue. Let's say we have let's choose this color. Alright, so we have three colors. So now I'm going to cluster based on the PC data. So we're going to when we are clustering, we are not going to choose race. Okay, I'm going to remove the race. Just use the color so that I can color our data, but we are not going to include it in our data for clustering. So we are going to select PC1. Can select it to PC10 or more. So it doesn't matter. So it still work fine. Let's say we choose PC1 to 10. Alright. So we are not using this, okay? We are not using the race because it's not supposed to be included when we are clustering. You should be able to do that automatically by itself. So we're going to look at multivariate and clustering. So the first one is called classical clustering here. So this classical clustering is actually called hierarchical clustering. Okay. All right. So you can see that here we have our data cluster. All right. So we are having the data clustering routine procedure produces for us a dendrogram. Okay, dendrogram. So this is called dendrogram. This is common in R, in Python, and the rest of them. All right. So showing us how data points in rows now can be clustered. Okay. So now we have algorithm that it uses here. In this algorithm that it uses here, we have four of them here. All right. We have a UPGMA. There's a peer grouped. All right. And we also have the other one called single leakage, words method, and complete leakage. Now, what does that mean? UP GMA means unweighted peer group average. Okay, unweighted peer group average. This one cluster based on joined based on the average distance. Okay, between all members in the two groups. I mean, in the groups. Okay, in the groups we have three groups now. Okay, so it uses what they call average now. So but in the single leakage actually you use nearest neighbor method. Okay, cluster adjoint based on the smallest distance between the two groups. All right, that is what it uses, single leakage. But we have also a words method which cluster based on the join such as the increase is within group variance, which is minimized. Okay, in that case, the cluster joins such that increase in within group variance is minimized. That is a word method. So I think word, as far as concerned, it seems to be the best method so far. Okay, because it uses directly Euclidean distance to measure, and it is inherent the uh, to the algorithm. Okay, and we also have complete linkage, which means this cluster are joined based on the largest distance within group. Okay, so single linkage with shorter distance and the complete linkage larger distance. All right, so we can see that we can rotate here. If you want to rotate your graph, you can click on rotate here to change the direction here. So you can rotate. So if you check here, what is to be the best? If you check it there, so this is a board you can compute. Alright, so I compute now. So it's effort to classify. You can see that the black, we have more black here. Help us classify them into three. We have more black here. Okay, in this category, we have more blue here, and we have more of a pink here. Okay, so this is just help us classify our data without a labeling. Okay, that target variable. So you can see though there are some mixture of a pink here in the blue and in the black, but we can see major of black and major of blue around here, around the middle here. So that is which means Africa. You can classify Africa, cluster Africa here, but cluster Asia here, and European here, more here. Though you can see European mixed with some part of Asia here, but more. But at least you can see how they classify. So this is basically called hierarchical clustering or classical clustering. So like I said before, you can see correlation is 0.5, right? So though it's not that much, but at least so you can if you use word cannot change the similarity index, right? Because it's inbuilt for the distance. But if you use other method like a peer group, you can change. So that is that for that. So I will see you in the next class where we look at the other clustering. Thank you so much for listening. You can save your work, uh, generate you can export out the image if you want, change the size here, or you can also save as any PDF you want or TIF, whichever you want. The ball is to your court. Thank you so much for listening. I will see you in the next video.